All right, I apologize for the green paper. I am out of the white ones, but we are going to start going over 1 through 5 for week 9. So EMI 502 is the standard that you have had before, and it's about figuring out if something agrees or disagrees with the passage or the figure. So remember, the first thing we do is always go to the questions. So does the passage support? So that's going to be agree with. The solubility of all compounds will increase as temperature increases. So first is read the question. Then read answer choices and find KTs for both our key terms. So solubility increase, temperature increase. That's what I know I'm looking at. So all 3 compounds were the lowest at 0 degrees. None of the compounds has a thingy of 0. No, because he releases heat. No, because the solubility decreased. So already, I'm going to go ahead and cross off B and C because they don't have the key terms of solubility or temperature. So read the answer choices first because you can cross off ACs that don't use key terms. And I haven't even read this yet. So now let's look. Now we need to look at the solubility. And it says that the solubility increases as temperature increases. So we have that here. We have that here. So that's confirmed. Confirmed. And then, no. So no, for this one, whatever activity 3 is, activity 3 is CaSO4 decreases. So I didn't even have to read that, but that was just to be sure. We were between a yes and a no, and automatically we're a no because activity 3 shows a decrease. 3. All right, let's try number 2 with that method. Based on figure 1 and figure 2, is KNO3 always more soluble than NaCl at the same temperature? So our answer choices need to be talking about NaCl, KNO3, and solubility. So, because the solubility of KNO3 at 100 was higher, yes, because KNO3 releases more heat when dissolved, nope. No, because the solubility was lower, no, because it absorbs more heat when dissolved, nope. It doesn't talk about solubility, so we can cross that off. So now we're between A and C. We just need to figure out if it's yes or no. So now we go to where it goes. Figure 1 and 2. So figure 1 is NaCl. Figure 2 is KNO3. So let's see. At 100 degrees, this is 250. At 100 degrees, this is 39. So let's look at the numbers here. 0 to 250 and 35 to 40. So this only has a range of 35 to 40, and this has a range of probably 25 to 250. So at 0 is the only time it might be a little bit higher. Let's see, at 10, at 20, this is like 45, that's 36. So those first 2 temperatures are the only ones that we can really say. So let's see. No, because the solubility at 0 degrees was lower. So we can say that based on our graph. Because 100 degrees, this proves our point, but this one disproves it. So the answer for 2 is C. All right, number 3. Does figure 1 support the statement that the solubility of NaCl reaches a minimum between 20 and 80 degrees? So that minimum, that's going to be lowest. Is it the lowest at those temperatures? NaCl. So solubility did not vary significantly because NaCl absorbs heat when dissolved in water because it releases heat. So we can cross off B and D again for these ones because those don't have our key terms. So no B, no D because the key terms don't match. No, because the solubility of NaCl increased steadily, and no, because it did not vary, or yes, because it did not vary significantly. So now let's flip back to these 20 and 80. What happened at these temperatures? So between these 2 times, I'm seeing a pretty big increase. So I'm going to say it increases the whole time. So that's probably going to be a no because it increased steadily over the range of temperatures. And I knew from before that that matched answer choice C. All right, number 4. Do figure 1 and figure 2 suggest the solubility of KNO3 is more sensitive to temperature variations than that of NaCl? Solubility was higher than the solubility of NaCl. Yes, because between 0 and 100 the solubility increased by a factor of 10, while NaCl increased only slightly. No, because the solubility of KNO3 was lower than the solubility. No, because sensitivity to temperature variations cannot be determined from the information given. Okay, well, in these answers, if it's like an EMI passage, if it's asking you to judge something, so like suggest, predict, support, then you're not going to have it be like, no, that's a cop-out answer. So we're going to cross off D. This is what we call a cop-out. So, now, suggest that KNO3 is more sensitive to temperature. So, how's the solubility changing here? For NaCl, again, the solubility changes from 35 to 40. And from here, the solubility changes from 25 to 250. So I would say for KNO3, that's a bigger change, which means it's more sensitive. So I'm going to go with yes. So we're going to cross off C. And now, let's see. Yes, because at 100 it was higher. That doesn't tell me about temperature variations. That tells me one temperature, so I can cross off A. So that means that the answer is B. And the last one for this exit ticket, based on the passage, does the dissolution of CaSO4 lower the temperature of the solution? So, yes, because the solubility increased then decreased. Yes, because this for CO4 is negative. No, because the solubility increased then decreased. No, because this for CO4 is negative. First off, I don't really know what this means, so I want to find out what that is. And I actually do know what H is, but you guys don't. Or you might, but I haven't taught you. So, enthalpy. You learn about something called entropy and enthalpy in quarter 4. So, the students looked up the enthalpy of the solution. A positive value indicates the heat was absorbed, while a negative value indicates the heat was released. And we want to know, does the dissolution of CaSO4 lower the temperature of the solution? So, it's not really going to talk about enthalpy at all. Actually, I guess it does. But does the dissolution of CaSO4 lower the temperature of the solution? So, we're only going to be looking at CaSO4, right? So from here, as we increase the temperature, we increase the solubility. But once we hit 40 to 100, when we increase the temperature, we decrease the solubility. So, does the dissolution of CaSO4 lower the temperature of the solution? So our temperature wasn't necessarily being lowered. And then let's check. CaSO4, it's negative, right? So that means that heat was released. So, what does that mean? The dissolution really just means we're dissolving it, by the way. So if this is a key term that got you tricked, it just means when we dissolve it in solution, what does the temperature do? So does it lower it? So if we're releasing heat, that means that it's an exothermic reaction, so heat's going to come up. So endothermic reaction, that's like making ice cream from milk and rock salt. That and ice, that's lowering right there. But this one, you have to go, but if you release heat, that's like a fire. That's actually going to raise it. So the answer for this one is D. You actually did need to know a little bit of chemistry here, because you would have to know that heat released equals a high temp. So if you got that one wrong, you haven't learned it yet. Don't worry.